Hello and welcome to Dr. Anima Upadhyay's Chemistry in Technology and Chemistry Lab videos. In this video, we will learn about another important property of the lubricant, that is cloud and pore point. But before I start this video, I would like you to please subscribe to my channel and also to share my videos among your friends. Don't forget to like the video also. Let's begin with the definitions of the cloud and pore point. So, the cloud point is that temperature at which the lubricating oil on gradual cooling becomes cloudy or hazy. That is, it loses its transparency and it becomes cloudy in appearance, and such a temperature is called its cloud point. The pore point is that temperature at which the lubricating oil stops flowing and it is further below the cloud point. So, once the cloud point is reached, if the oil is cooled further, then it reaches a temperature where it loses its flowing property, and such a temperature is called its pore point. The cloud and pore point are temperatures and therefore they are expressed in either degree centigrade or in degree Fahrenheit. Now let's see what are the reasons why the oil becomes hazy or it stops flowing. So, the high pore points, usually they occur in the crude oils when it has considerable amount of paraffin in it. Paraffins are waxes and they starts precipitating with the fall in the temperature. At very low temperature, the liquid precipitates to the extent that it stops flowing, and this phenomenon is observed with both light oils as well as heavy oils. So, the paraffins that are present in the oil are mainly responsible for its cloud and pore point at which it loses its lubricating property because it starts solidifying and it becomes finally solid, which does not have any liquid property, that is the moving property. So, the cloud and pore point are the indicators of the lowest utility temperature of the oils. So, what is utility temperature? When we are applying a lubricant to a machine which has to work under cold conditions and that lubricant has lost its property of lubrication, that is called the utility temperature at which the lubricant loses its lubricating property. So, the samples should be examined frequently before applying to any machine working under cold conditions for its cloud and pore point, as it's a good way to measure the lowest temperature of the usefulness of an oil when it is used under certain applications. So, what is the significance or importance of determining cloud and pore point? The solidification of the lubricant at low temperature may result into clogging of the machine, blocking of the machine. Its determination indicates the suitability of the lubricating oil in cold conditions. Lubricant used in a machine working at low temperature should possess low pore point and a low cloud point. That is, the temperature at which the machine works is very low, but it's the lubricant which is applied to the machine, its pore point and cloud point should be lower than the working temperatures of the machine. Now, let us discuss how to determine the cloud and pore point. So, we employ the apparatus that is called the cloud and pore point apparatus, and the construction of this apparatus is very simple. It is made up of a flat bottomed glass jar about 3 cm wide and 12 cm long. The glass jar is capped in a copper jacket which is surrounded by a cooling bath. The glass jar is closed tightly with a cork which is provided with an inlet for thermometer. The temperature in the bath is maintained by filling it with a cooling mixture. Now let us see what are the various freezing or cooling mixtures that can be used or employed for cooling the apparatus. So if we want the temperature of the oil to be around 10 degrees centigrade, we can use a mixture of ice and water. But if we want the temperature to be below minus 10 degrees centigrade, we should use ice and salt mixture. That is the common salt, sodium chloride and ice. When mixed together, it brings down the temperature to around minus 12 degrees centigrade. But if we want much lower temperature to around minus 26 degrees centigrade, we must use a mixture of ice and calcium chloride, which brings down the temperature to minus 26 degrees centigrade, and a mixture of solid carbon dioxide with acetone brings down the temperature to around minus 56 degrees centigrade. So, in short, we can say that a freezer that can cool below 0 degrees centigrade is generally used when the temperature is decreased in the apparatus, and the temperature is decreased in the steps of 3 degrees centigrade until a cloud or a haze or a precipitate is formed at the bottom of the test tube. Here is the figure which shows the cloud and pore point apparatus. So this is the glass jar in which the oil is taken up to 5 centimeter height. Through the cork, a thermometer is inserted to note down the temperature, the fall in the temperature. This is capped in a copper jacket, and this is then kept in the cooling mixture. It could be any one of the cooling mixture which is shown in the slide, in the previous slide. So this is how the cloud and pore point can be determined using the cloud and pore point apparatus. One thermometer is also inserted in the cooling mixture to note down the temperature of the cooling mixture. Now let's see the working of the cloud and pore point apparatus. So the oil which is taken in the glass jar for the determination of cloud and pore point is first made anhydrous. That is, the moisture in it is removed by treating it with anhydrous sodium sulfate. It is then filtered using a dry filter paper, and then this anhydrous oil is placed in the glass jar to a height of up to 5 centimeters. This is the glass jar in which the oil is filled, and a thermometer is inserted in the jar through the cork. The jar is then placed in the cooling bath. As the cooling proceeds, the temperature in the oil falls gradually. With each degree fall, the jar is withdrawn to examine the formation of cloud or losing of the transparency of the oil. The temperature at which the precipitation appears is noted down as cloud point. On further cooling the temperature, when the oil stops flowing, it is recorded as the pour point of the lubricating oil. Here in this table I have shown you how to record the cloud and pour point. So at 9 degree centigrade there was no haziness and the oil was flowing, so it was further lowered to 0 degree, then -3 degrees, a cloudiness appeared and this was recorded as the cloud point. On further lowering the temperature at -9 degrees, the oil became solidified and this was recorded as pour point. So the results are shown how they should be mentioned. Now let's see what is the difference between the cloud and pour point. So the cloud point refers to the temperature at which a wax or cloud appears in the oil or fuel, whereas the pour point is the temperature at which the oil loses its flow behavior. So this is an important difference between the cloud and the pour point. When the cloud point is reached, the oil becomes translucent, that is, a precipitate or haziness appears in the lubricating oil. But at pour point, if the glass jar is tilted, the oil will not flow, it will stop showing its flowing behavior, and that is recorded as the pour point, where it loses its flowing property. So what are the requisites of a lubricant in terms of cloud and pour point? The requisites are that a difference of 4 to 6 degree Fahrenheit should be there between the cloud and pour point as a good lubricant. The pour point tells the temperature below which oil cannot be used as lubricant because it will stop flowing at the pour point. So such oil should be discarded as lubricant. The cloud point indicates plugging of the filters or small orifices under cold conditions. Cloud and pour point also tells us the suitability of lubricating oils in cold conditions. This point, that is the cloud and pour point, has to be predetermined before they are being supplied to the market as lubricants under cold conditions. Because if a machine is working under cold conditions and a lubricant is applied to it which becomes solidified, which becomes solid, then it will be no longer a lubricant under such conditions. It should not be applied. It should be discarded. Thanks for watching this video. Hope you are gaining good knowledge out of my videos. Don't forget to subscribe to my channel. Keep watching and bye-bye.